In this step, we will use a 2D high-speed area mill. 2D high-speed area mill generates free-flowing motion needed to machine features, such as standing bosses and cores or pockets in a single operation. With area mill high speed, smaller depths of cut are recommended, versus dynamic mill in which the depth cuts can be the size of the flute. Click the Expand icon in the 2D area. Then select Area Mill. In the chain options, enable From Outside and click on Select Machining Chains. Select the first chain. Then press OK. Click on Select Avoidance Chains. Select the outer ellipsis and press OK. Then press OK again. Click the Preview Chains button and minimize the dialog. Press Escape. Then click on Tool from the Tree View list. Click on Select Library Tool and click Filter. Select None, enable the Flat End Mill, and change the tool diameter to equal 0.75 and press OK. Select the 3/4 inch flat end mill and press OK. Then enter the comment, machine the elliptical shape as a boss. Select Cut Parameters. Enable corner rounding and change stock to leave on walls and floors to 0. Corner rounding replaces sharp corners with arcs for faster and smoother transitions in tool direction. Max radius is the largest arc that you allow Mastercam to insert to replace a corner. Larger arcs will create a smoother toolpath, but with greater deviation from the originally programmed toolpath. Profile tolerance represents the maximum distance that the outermost profile of a toolpath created with the corner rounding can deviate from the original toolpath. Offset tolerance represents the maximum distance that a profile of a toolpath created with corner rounding can deviate from the original toolpath. This is the same measurement as the profile tolerance, but is applied to all the profiles except the outermost one. XY stepover expresses the maximum XY stepover as a percentage of the tool diameter. Mastercam will use the largest value possible that does not leave unwanted upstands of material between the passes. Keep tool down within keeps the tool down if the distance from the end pass to the start of the next pass is less than the value here. Mastercam will not create a retract move as defined on the linking parameters page. Instead, the tool will stay down and move directly between the passes at the feed rate. Select Depth Cuts. Enable Depth Cuts and change the max rough step to 0.25 and change the finish step to 0.05. Select Transitions. Make sure Skip Pockets Smaller Than is set to 0.55. Entry method sets the entry move that the tool makes as it transitions to new z-depths. If you choose to create a helical entry and there's not enough room, Mastercam creates a ramp entry instead. Entry feed rate sets the rate that the tool feeds into the material. Z-clearance is extra height used in the ramping motion down from a top profile. It ensures the tool has fully slowed down from the rapid speeds before touching the material. Plunge angle sets the angle of descent for the entry move and determines the pitch. A smaller plunge angle means that the entry move takes longer to descend into the z-axis. Select linking parameters. Enable clearance and set the value to 2 absolute. Ensure retract is enabled and set to 0.25 absolute. Ensure top of stock is set to 0 and change the depth to -0.75 inches absolute. Then select HST leads. change the vertical arc entry to 0.25. HST leads allows you to specify an entry and exit arc radius value for the 2D high-speed toolpaths. The arc is created vertically to lead on and off the material. Choose Arc Filter Tolerance. Enable line arc filtering settings. Select OK to accept the warning. Ensure Create Arcs is set to XY. And use maximal tolerance value for both. Tolerance distribution allows you to dynamically adjust the toolpath's total tolerance. Total tolerance is the sum of the cut tolerance and the line arc and smoothing tolerances. Move the sliders between the cut tolerance, line arc tolerance, and/or smoothing tolerance fields. The ratios update in 5% increments and the toolpath's total tolerance remains at its current value. Line arc filtering settings allows you to activate line arc filtering for the toolpath and apply the settings you define in this section to the toolpath refinement. Toolpath filtering lets you replace multiple very small linear moves within the filter tolerance with single arc moves to simplify the toolpath. Smoothing distributes a toolpath's node points, avoiding the clustering and grouping of points that can cause marks and other imperfections. Create Arcs In creates arcs in the selected plane. Your post-processor must be able to handle arcs and output the code to select this option. Press OK. Then, backplot the toolpath. When backplot is finished, press OK. Then, verify the operation. Change the view to isometric and fit to screen. Then press play. Minimize the simulation window. Change the view to top and fit to screen.